Hi everyone, this is Ashwin here. In this video, we are going to see how to segment image or video using a pre-trained model called SAM 2.1. So this model is released by Meta, and it can segment any image or video without doing any training. So this will be a pre-trained model, and for image or video, you can either give a bounding box or a single point where you want to segment that object, a person. It can be anything. So in this video we're going to cover like both formats like image and video, and segment particular areas of the image using it. So whenever we give a point from an image or a video, it will just track that object throughout the end if it's a video, and you can also extract that particular portion of the image with the bounding box coordinates that the model will present. Okay, let's install the module which is needed for this. I'm going to use Ultralytics for this one. So pip install QU, that is quiet upgrade Ultralytics. Okay, so if you don't install this module, just install it, and in the backend it might use PyTorch. So if you are having like NVIDIA GPU, means make sure to install PyTorch with the CUDA support for faster protection. Okay, once that is done, we will initialize the model. Initialize SAM model. So I'm using a 2.1 model. There is like previous version like 1.0 and 2.0 as well. You can check it in the documentation if you want to use like previous models. So from Ultralytics, import SAM, and I will also import matplotlib, pyplot, as plot, then load the model equals SAM. Just pass the model name. For now I'm going to use like base model. You can also use different models like small model or large model as well. You can again check that in the documentation. For me it just works better if you have like a CPU without any GPU support. So this is the model name. If you don't have the model present in the project directory, it will download the model. Otherwise, it will just reload the model that is present in the folder. Okay, that's done. And display model info, model.info. Run this. Okay, it loaded the model, and this many parameters and gradients we have, and it has around like 403 layers in this model. And then we have to like have an image. So I will just use the image that I have downloaded from Ultralytics. If you want to download, you can also like use any type of image that you want. So you can get the image from this URL, https ultralytics.com/images/bus.jpg. So this is the URL. I already downloaded it, and I also have like a test video. I will upload everything in the code repository. So here we will have, first we will define like bounding boxes. I'm going to show like two different approaches. So B boxes, let's command this, define bounding box regions. So B boxes equals, so you can pass like multiple bounding boxes. So it's like a multi-dimensional array or list. So 100, 100, 500 and 500. So this is the start X and start Y coordinate, and this is like ending coordinates x and y. So if you have like a image with a different resolution, try to get the starting and ending bounding box using some online tool and provide the coordinates here. If you are using some other application, you can also do that. Let's say if you are doing some YOLO object detection, and it might already give some bounding box for those particular objects. Then later on you can segment those images separately using the model. Okay, now this is define and segment image. Now image path, test image .jpg, then results equals model of image path points equals, you can sorry, this is for points, so for bounding boxes, b boxes, and you can pass the b boxes here. Okay, now let's run this. Okay, let's display the result. For result in results, so for each bounding box or segmentation image, we can visualize that using this snippet. So this is the bounding box coordinate, like 100, 100 and another 500 and 500. You can see it tried to like segment this bus from it. Maybe we could increase the dimension. Okay, let's try a different bounding box coordinate. 55, 400. So this represents the person in the image, and here it will be 230 and 900. Let's run this. Now you can see it just segmented the whole person from the image. So like this, if the YOLO detects some object or person, and if you pass the bounding box, it will just segment that person alone. So if you want to just take out the pixel values and just crop out this person alone, you can also do that. And the other approach will be again results equals model of image path. So this is bounding box. So here define points. So you just have to like give a single coordinate. So given points, you can also pass like multiple points if you want to like separate like two objects. So points equals, again it will be a multidimensional list. So 350 comma 370. So this will be 1 point. Let me pass the argument. Points equals points, and you have to pass the labels. Labels will be 1 for now because we just have like a single point. If you want to like differentiate between like multiple labels, you can also pass the labels here to segment it appropriately. Let's run this, and we will use the same snippet. Now you can see based on the coordinate, it just highlighted the whole bus, and we can also segment this whole bus from this image. So this is like a single point. Define single point. We will reuse the same for like multiple points. Let's have like define multiple points, pass the points here 100 and 650, and labels will be 1 and 0. Run this, run this. Now you can see it just segmented the person, or just the person clothes, but mostly it's just segmented the whole person, and it segmented the whole bus, and both of them are like different classes at the moment. If you do some object detection using YOLO, it will have a class for each bounding box. So you can, if you pass the labels accordingly, each one have like separate colors. So the persons will have separate colors, and the objects will have separate colors accordingly based on the class label. So this is it. And then if you want to like extract these images, we can also do that. Okay, now let's extract the bounding box images from the results. Extract bbox image from the original image. Okay, for this I'm going to import CV2 and import torch, because as I said, backend is a PyTorch module, and NumPy. Then we will load the image using cv2.imread of image path, which we have, and for I comma result in enumerate of results. Again, if you have like multiple results, the for loop will help. So if has attribute of result comma boxes and result dot boxes is not none, then boxes equals result dot boxes dot xy dot CPU. I'm just converting to a NumPy array, which is easier for processing if you are dealing with OpenCV. If is instance of result of boxes dot xy comma torch dot tensor. If it's a tensor, we will do the conversion. Otherwise, else np dot array of result dot boxes dot xy. Okay, so this will get you the coordinates of the boxes, and then we will iterate through the boxes. Iterate through the bounding boxes. For j comma box in enumerate of boxes x1 y1 x2 y2 map of int comma box of, just need the 4 coordinates, then cropped image equals image of y1 y2 x1 x2. So this will just crop the image from the original and then show the image using cv2 dot im show of cropped image. I will have I underscore j for uniqueness and then pass the cropped image. cv2 dot weight key of 0. Finally cv2 dot destroy all windows. Okay, that's good. Let's run this. Okay, list has no attribute boxes. So this should be result. Okay, now that is clear. Let's try to run this. Now you can see this is the cropped image of the bus, and if you press any other key, now you can see this is the cropped image of the person. So like that you can just crop the images that you need using these coordinates, and it also have like segmentation like pixel values, so you can also just extract these person image just using the pixel values alone. So that is also possible. I'm just showed you an example for how to use the bounding box, as it's simple to use. Okay, now this is done. You can also see how the result looks like. So result dot boxes dot xy and xy. See, so this is the tensor values and the devices in CUDA. That's why we have to like change to CPU and use NumPy. Okay, now let's do the same for video. Segment video. So for this we will import module from Ultralytics. From Ultralytics dot models dot SAM, import SAM2 video predictor, define model params. So overrides equals dict of confidence equals 0.25. Task will be segment, mode equals predict, then image size equals 1024. You can also give any size that you want, like 512 or 720, based on the resolutions that you need. Model will be SAM 2.1 base. So this you will pass it to the predictor. So predictor equals SAM2 video predictor of overrides. So this is the confidence level of the segmentation that it does, and we will use this point method to segment a particular object from the video. Let's run this. Then video path equals test video mp4, then results equals predictor of source, which is video path, and points equals 900, 820, and then labels equals 1. I'm just going to segment only one dog from a video. So this is like a dog commercial video, just like 3 seconds video. So it will try to segment it for each frame and store the result video. And if you want to have like multiple points and track multiple object and segment it from the video, that is also you can do. Now you can see it just processing frame by frame. Totally we have around like 2 to 3 seconds of video. So it's running fully. You can also do streaming. As you can see, stream is also possible, so that we can show the results like frame by frame using OpenCV, obviously, and the results are saved in this folder. So this is the folder I have. If you go to segment, predict, so this is the test output video. Now you can see the dog point. I just share the initial point of the dog, and it just tracks that dog correctly over the course of time. Like that, if you have a YOLO object detection model, and if you just predict object from the first frame, it can just do the tracking till the rest of the frame. So this is as easy as it is, and you can just do multiple image processing techniques using this. If you want to like remove all the background except the segmented object, you can also do that. So the applications are many for this use case. It depends on the application that you are using. Okay, so that's done. So that's pretty much it, guys. We have done segmentation for both image and video using different options like bounding boxes and point-based methods. And maybe in future videos, if you want, of course, if you can leave a comment below. If you want to use object detection and do the tracking continuously, we can also do that. So that's pretty much it, guys. If you like this video, hit the like button and don't forget to subscribe the channel for more videos like this. Stay tuned for the next video.